Uh, so apparently Visual Studio was so kind to recover me a file, and all it recovered was a new line character. So XD. But okay, yeah. I want to do a really quick stream. I'm very tired, but I just want to have a daily stream done. And um, this probably is actually if then else because we are very JI inspired, right? So we just keep consistency where we can, I think, and probably will say make for loop more JI, like e.g. for IO10, like this, meaning 0 to 10, something like this, right? I think that's useful. I need to read an entire book to know how to optimize this language, honestly. It's just kind of sad. But I can do some like low effort optimizations that I know of, but it's just I just realized like the book that I read was pretty to the point, but it also didn't cover everything. Didn't really cover many optimizations. I think I did a pretty good job on explaining like parsing, and I already had parsing because of some other thing I watched. So I think like parsing on its own I know well. Resolving, sure, that's good too. And of course I'm not actually compiling to assembly. I think my bytecode is decent, but I still would like to actually optimize the AST because, like, for example, if I say this, right? Say my var equals this. This computation instead of being done when the file is first compiled, this is only done when this code actually executes. So this means basically spending time when the game is running. And that's stupid because this is like literally here. And if I have something like a const, right? It's a const. That is also pretty much the same thing. And then if I have another var, but I know that my other var is like, I don't know, p, then I also know this var, right? Even though this is not const, I know that at this point it's actually unchanged because there's no writes to other var here. And even if there were, like we say plus equals 3, since this is a stack var, we could like, I don't even know how I would exactly do it because this is like replicating all of the bytecode execution, but on compile time, pretty much. So not exactly sure how to do that well. But in this case, this could literally just be substituted like this. And this var could even be removed completely from runtime. And we could just have this in the bytecode. And actually not even done. Actually, you'd just have 15, 3, and it's 12.0. So we would just have this, right? And since my var is not even used, it's probably I did not even have done, right? So, and that kind of elimination is like pretty simple. The less simple thing is evaluating stuff. So I have not really a good idea of how to do all that optimization. I'm going to do that today. What I am going to do is do enums, and we'll say my enum is 1, 2, 3. Actually, 3 I will define. 1 I will also define. Or no, actually I will do this. We'll make this like this. So this tests more things. I actually will add a comma after the last one to make sure that actually works. Okay, how do I do this now? This actually should be my enum, or maybe some numbers, right? And now what we want from this feature is actually being able to say this. So this is like sort of like a namespace. And enums are purely syntax thing. They are not actually compiled to anything. They don't have a runtime effect. They're just text substitution, basically. You could think of it. Yeah, you could think of it like that. Basically, they're like integer literal or something. Okay, so let's see when we have declare function. We'll also have a struct enum declare. Not sure what to have here. We'll have string name, right? And we'll have a list of enum key value, maybe enum values. Maybe use enum value as a struct, right? So enum value, what it is, it's a link of enum value. Link is a string name and it's US64 value. We'll move it here. And actually, I think what I'll do is I'll have a struct enum string name. So I'll just have this. Actually, I will have a hash map of enum of values, and this will also I think this is what I can. Right. And this could be straight up inside of the hash map because this is an 8-byte value, right? And enum. Okay, let's parse this. So declare function. Actually, this will be very simple because if we do if we accept a lecture, accept token, lecture identifier. This actually is a keyword name, so we'll say enum. So this is when we return a statement enum just push statement parser arena statement type declare enum and the token being 1. Let's just parser current, right? Parser lecture current. Okay. It's just AST arena, right? And now we didn't add enums here yet. Will do. Hmm. Let's think about this. What do I want? Uh, so what I want here is to declare enum name equals bootstrap. It would be a parser AST arena, right? And we would do the identifier on, right? Okay, so what we do here is we accept keyword, or rather Lexer expect token parser Lexer expect token type and parent, and it's like expected open parent after enum. I think what we have to do is add enum here. So let's actually just have this here, right? So that's what we can do immediately. And now say, I guess, I'll do while. Maybe actually just while true is the simplest thing we can do. And now what do we say is Lexer accept this parser Lexer enum name. Maybe just name, we'll say Lex token name equals this. Okay. Do I just, I guess I just have it here in enums. Kind of weird thing. Okay, and now what we say is we could accept, if we accept a token Lexer parser Lexer Lex token type colon, right? So 0. And we actually expect another one, parser Lexer Lex token type colon expected double colon for enum assignment, enum value assignment, right? This. I'll say here is value equals 0. I'll say next value, and then x to value equals next value plus plus. I'll just win. And then I guess next value equals value plus 1. Right. But in case of this, we actually want a lecture. Here I actually just want parser or read primary. But the thing is, I just want a value. I straight up just want this. But okay, right now. Runtime value, runtime type, int is what we actually want. So, or expression value type isn't this, right? But this would be actually expression type value. That's what I'm thinking of, right? And if it isn't, then we just say compiler, or rather parser error, parser invalid enum value, right? And otherwise, we just use expression value integer. Or maybe I actually invert them. I think it makes more sense because the error case is very short and the implementation case also short. Well, what we would say is value equals the int like this, and then we would also expect a semicolon. Or rather, we actually just expect this is like this. So this is HashMap on. Name and then value. Here, if we don't accept, actually, we kind of need... Do I not have expect? I do. Okay. And here we would just say expected, what do we expect? We expected a variable. We expected enum name. Okay. This is name token, and name is actually push spring parser AST arena name token out. Actually, if pushing strings to AST arena really makes any sense, because technically, we don't free the file contents until the AST is freed too, so they like share a lifetime, so duplicating doesn't really make much sense, but whatever. Something I can refactor later. And now here void star is just the value. Straight up. Okay. And then at the end we say parser actually This is weird because parser requires me to have. So stupid. And here we would just say enums, right? And we would say the enum let's say this, right? And we would actually use oh we find it so annoying. Let's call this result. Right? And then enum equals result. This, right? So now enum name. Okay. And now, okay, what we need to do here is we need to lexer accept token, right? Parser lexer lex token type comma, right? And now if so, then if we also accept a close brace, close paren, paren, I don't think that's paren actually. It's brace is what I'm expecting. Right. And now if we have close brace and we break, if there's no comma, we actually need to expect a close brace because expected close brace after no comma. Right, I think that doesn't. Let's see if we get anything useful out of this. I think we did. We have values, we have let's see this enum values, right? As we say, and we say keys, right? This is actually a value, so now don't want to start. Now we have 8 keys, and we have 0, 2, 3, and 1. Okay, that seems correct. Now when we free NIST, I think what I'm gonna do is because hash maps are fucking annoying to work with because you have to manage their memory. So I think what I will do here is I will just say a link of enum link. And I will have a list of enums here. Or rather in here. Enum. This enums for the allocation of hash maps. Enums list maybe. Okay. That's annoying. I don't want to do that, but I have to. Enums list, enum. This. Okay. And this is almost actually here, right? And like this. Okay. Yeah, so that's actually fairly simple, right? Now what we need is a dot operator. I think I already parsed on, right? I do. One thing that I found is kind of stupid about what I did with casting. We have unary. So technically right now we allow you to say cast S64, like 1.5. And instead of having the minus here, you would have it here. And same for like exclamation mark. I don't know, it's kind of stupid, but maybe... I don't know. Maybe that's fine actually. Maybe hey, that's not something I should worry about. Is there one function, right? They're technically separate ifs, but technically like this, those conditions are mutually exclusive anyways. So there's not like this has more priority than this. But yeah, anyways, I guess what I need to do is say if we accept a token parser lexer lex token type, right? If we have this, this means we want expression type value. Just like enum value maybe for now, and we'll say this. So this is after normal value. What's up, REO1? I'll say here we'll have an enum accessor, say name. We have subname, enum value. Start operator currently only is related to enum values. That might change, but okay. I think that does it, but technically should probably just to be careful. Is if I push string and this is, and if this is null, then just no push happens, I think. Well, I don't currently do that, but probably what I should do if no string size, maybe here we just return result. And this is so we don't push null terminator. But maybe we should. It's kind of dumb. I love it as it was. Okay. Okay, let's now print the enum value, right? So print. And what I'll do is I'll print a scope. This enum value. Okay, now we should be able to see that in the printout. Now in resolution. Well, the weird thing with enum type is sort of how it. It's so weird how I didn't know. I think this hash table I added here needs to be eliminated. Right? Yeah, that makes more sense. Yeah, actually, when we free the Kairos AST, what I need to do is iterate over enum equals AST enums list first. So you can call this enums. AST, so this is enum, and then enum equals enum link next, right? And we'll say free or free hash map, right? Enum values like this, right? But if I had a hash map in the AST directly, that would basically mean that every enum is global scope, and I actually don't want that. I want them to sort of behave like constants. Although constants are not fully implemented in the resolver, really. They're only like bound for the global scope. So enums will behave the same way for now. Okay, so now what the types code needs to do is it needs to have a hash map for enums. I was thinking of making this one hash map that actually has like a symbol, maybe, right? It would have symbol type. Have symbol type invalid probably, right? Would have variable function enum and count, right? This is something I want though. I have no idea. I'll try now. And here I think I actually need to store this as a pointer. Yeah, okay. Then it's fine. Here we'll say symbols. And now I don't actually have to say this. That's neat. Here I think I can just say string name, and what I would say probably is symbol type. Right. Get type symbol probably is what I should call them. Type symbol. Symbol is such a weird word, honestly. Type symbol type. I don't know. I don't know about that one. And here actually I'll say none. And now if the type should be symbol, right? And now if type, we would want to check if the symbol type isn't the type, right? So if we pass a null type, that means we accept anything, and otherwise we would say resolver error, resolver token expected different symbol type. And then you can just remove. Cell name, and what you say here is 0 or symbol time none. Say expect type, maybe. Actually, no, that even works. We'll think about it in a sec. Say that the symbol type is symbol type variable. Say symbols, symbol. Like this, symbol. Okay. And basically, same thing here. Just we say as a function. We say it's a function, right? And it's the function. So we can remove. This is a type symbol. It's probably function name instead, right? Function, and now what we also have is declare enum. And this is just an enum, and actually this is even simpler because, oh no, this still needs to be this, but enum equals enum like this, right? Symbol, and we don't have to increment this, and here we just say enum name like this. Same here. Get symbol, get type symbol. Symbol type function, right? Symbol. I guess same thing here. If expect time, we would just say resolver error expected a symbol, right? Then that makes sense, right? If you expect a certain type, that would mean then. I have made it completely not confusing. Let's call this just symbol. I'll say find symbol. Symbol. Say symbol type variable. Yeah. Another weird thing is if there's no symbol, then we probably I probably say 0, right? And all I do is I just break here. Symbol var slot, symbol var type. Like this, right? And if no symbol, we say this, and here's the symbol function. Symbol func. So what I like about this is that now it's impossible to have symbol collisions. That was stupid because technically you could have two things of the same kind. And here actually what we need to do is symbols. Symbol function, symbol type function, right? And here's func, the func. Here what I need is symbol, right? Get symbol, or rather find oh my god, no. Find symbol, symbol type variable, symbol. Symbol var slot, symbol var type. Here's a name. Okay, let's probably have to paste here. Expected expect a symbol, but it doesn't exist. I should make those actually be formatted with I probably need to make this have like dot 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 and make it actually support the, like all the printf stuff. That would be useful. Okay, so now here this is like this, and this is like this symbol for type. Same thing here. No symbol. This symbol var type. Expression token. Expression identifier. This probably is wrong. Yeah, identifier up. And what's wrong here? So this is function call. We can just copy from here. We'll say, yeah, this is literally function call. This is function. Okay. I think that does it nicely. See what we get. And actually, case expression. So actually, one second. Let me actually test this without enum.cn. Alright. It works. Great. And now if I want to define a print as one, it wouldn't work, right? Yeah, print is actually not a native function. Now that's very interesting. So you can shadow native functions. That probably shouldn't be possible. The thing about that. Huh. Not sure. Well, for now, let's leave it as this. And let's add a statement type. So whenever we have declare function, I would also say declare enum, and what we'll do is actually not pre-resolve anything. All it does is add symbol or declare enum, right? Resolver. Resolver global type scope statement token, and the enum is statement enum declare enum like this. Right? Yeah, this is literally exactly the same for when we do a function. Like the order to be the same here and there. Okay. Just the only difference is that actually we just use a local type scope for this. Okay. Actually, we still don't print that correctly here. So when we have declare function, declare enum, say it like this, say enum equals statement enum declare enum like this, and we say under stuff, say enum name, right? And now for each enum, that's actually sort of tricky because we have to iterate over a hash map. So I think what we do is say values like this, right? Maybe even better, we'll say this values. Pop this like that. Okay, and now we'll say eyes enum. Yeah, this is not gonna be a sorted printout, by the way, because it's a hash map. size plus plus. Actually, this is over capacity. And now if enum dot values dot keys on I size is set, right? There's actually a key. What we would do is we would say would print depth, right? We will printf this, right? And string format the value, which would be an enum value equals essentially this, right? Oh, this is just S64, right? CP custom, and we'll say enum name, and then percent LLI. Say value like this. Okay. That should do it. And now to print it, I actually need to go to the runtime, or rather, it's parser? What is it? So here is where we would print the AST. And yeah, actually have to uncomment it. Like this. So it seems like need to do this here first. And the other thing is also that I would have to say this actually. This. Now we have 2031. Yeah, they are not the correct ordering. It's because it's a hash table, so they are not sorted. Is the thing, right? And I guess to make this a little bit more readable, I'll say continue like this. Okay, and now for parser, when we print the AST, I would actually rather none. That's messy as fuck. And now the other thing now is expression type. This is after value. Results type is just always runtime type integer, right? And same for the other mention. So here, right? And now actually this probably needs to say enum value name. We actually resolve it eventually. We actually want to resolve it eventually. I will say value equals. And here's where we would fetch the symbol like this, right? Probably do it like this, honestly. We'll say enum. And there's no symbol when we break. Otherwise, we say symbol enum. And this is our enum. Like this. And we would say hash map find, say this, right? Values would say Obviously here what we need is enum value name. And here on the other hand we need the subname. And the value will be our so this is a casted to a void star, but it's the unres of our S64 value equals 0. Like this. And if we find it, we say this. Right? We say it's the value. But otherwise, we actually just have a resolver error. Server expression. Say invalid enum value. Maybe subname, right? Should do it. And now, what do I want to say? The same thing. Okay, and now the last thing we actually need is for the compiler. Actually, what we do is for the statement type. So for when we have a statement type of the kind declare enum, we actually do nothing, literally nothing. No runtime effect, right? And then I should move to here. Where is it? So after declare function is where I put it. Okay, and now expression on the other hand, which should be after value, which is completely incorrect place from what I'm seeing. But basically this is the same thing. It's just instead of expression value, we say one. Yeah, it's this. Okay, confused for a second. Actually, I think what I should do here is make it a runtime value, maybe. Maybe not. Saying runtime value would be something like this. String value type equals runtime value. And the value and would be actually this, right? And now what I do here is value, I think, right? Okay. And I think that should now just compile. The reason we don't compile that is because we have not added a thing here. It's actually unrelated to that. It's related to declare enum. And it's this. We actually need to say like that. So otherwise enums will be defined twice. Okay. Now let's see if it works. Say print numbers 0, numbers 1, numbers 2, numbers 3. It does. There we have it. We have enum support. Actually, let me say so enum. That's already done. Pretty epic. Support. Get on, get comment, progress from stream 13 May 2023 enum support. Add enum support like this, or maybe this, whatever. Yeah, and that's it for me today. It's a quick stream. I'm pretty tired. Like I was saying, but yeah, it's pretty good to have enums. And yeah, we'll see you tomorrow.